Have you ever wondered why, after all the rockets, the telescopes, and the satellites, there are still things about our universe that even NASA cannot explain? Subscribe right now, because tonight we're diving into mysteries so deep that even the smartest minds on Earth are left scratching their heads. For decades, NASA has pointed its eyes to the stars. We've landed on the moon, sent robots to Mars, and launched spacecraft that are now so far away they're drifting beyond the edge of our solar system. But the funny thing is, the more we explore, the less we seem to understand. Every discovery seems to open up 10 new questions. In this video, we're going to talk about the strange, the unexplainable, the cosmic puzzles that NASA still hasn't solved. Dark matter, black holes, ghostly signals from space, and the endless question of whether we're truly alone. Think of this not just as a story about science, but as a night drive through the unknown, slow, dreamy, and endless. So, close your eyes if you like, let your body sink into the chair, and let's drift together through the mysteries of the universe. Now, here's the thing. Most people think space is just empty, a cold void. But that's the first mystery. It's not empty at all. It's buzzing. It's alive with radiation, with invisible matter, with signals that we can't always explain. Imagine standing in the middle of a giant ocean at night, water stretching out in every direction. You can't see what's beneath you. You can't see what's ahead. You can only feel the waves and hope you're not alone out there. That's what space is like for scientists. NASA has tried to answer the biggest questions, but some of them are still hanging, unanswered, like shadows at the edge of the room. Let's start with one of the biggest, dark matter. Here's the wild thing. Everything you see, every star, every planet, every galaxy, makes up less than 5% of the universe. The rest, it's invisible, unseen, untouchable. Scientists call it dark matter and dark energy. And the truth is, they don't really know what it is. They only know it's there because galaxies spin in a way that doesn't make sense without it. Imagine watching a merry-go-round spin. The horses should fly off, but they don't, because something is holding them in, something we can't see. That's what dark matter is doing to the galaxies. And here's the kicker. If dark matter disappeared tomorrow, the universe would fall apart. The stars would scatter like dust in the wind. Yet, despite all the telescopes, all the satellites, NASA still can't grab it, can't touch it, can't pin it down. Now, think about that for a second. We build cities, we fight wars, we worry about money, about work, about little problems every single day. Yet, 95% of the universe is something we don't even understand. Doesn't that make you wonder how tiny all our daily problems really are? But dark matter isn't the only thing that keeps scientists awake at night. There are sounds, yes, sounds in space that no one has fully explained. For example, during the Apollo missions, astronauts reported hearing strange space music when they circled the far side of the moon. NASA didn't release those recordings for decades. When they finally did, people were stunned. It wasn't static. It wasn't radio chatter. It was eerie, like a cosmic hum, echoing in the silence where no human had ever been. Imagine being up there in that tiny spacecraft, knowing the whole world was on the other side of the moon, out of sight, and hearing music that no one could explain. Would you be calm? Would you tell anyone? Or would you keep it to yourself, thinking no one would ever believe you? NASA eventually said it was probably interference, but many astronauts weren't convinced, and neither are a lot of scientists. It's one of those stories that makes you wonder, what else has been heard out there that we still don't know about? And this is only the beginning. The universe is full of signals, whispers from the dark. Some are simple radio bursts from dying stars, but others defy explanation. Mysterious fast radio bursts that light up the skies for only milliseconds, coming from billions of light years away. They flash and then they vanish, like cosmic Morse code. Who's sending them? Nature? Or someone else? We'll get to that in a moment. But first, let's slow down, take a deep breath, and remember, we are floating on a small rock in the middle of a vast ocean. And tonight, we're here to drift deeper into the waters. After hearing about dark matter and dark energy, the universe feels a little bit like a giant puzzle box. A box where most of the pieces are missing, and yet somehow the picture is still hanging together. But here's where it gets stranger. Almost like the universe is whispering secrets through static. Astronomers began to notice something odd in the skies. Short, sharp flashes of energy. Bursts that came from no star we knew, no planet, no galaxy cluster we could trace clearly. Just bursts. Imagine listening to a calm night, maybe the faint hum of insects, and suddenly there's a sharp knock on the window. That's what these signals were like, quick taps across the cosmos. They call them fast radio bursts, or FRBs. Each one lasts just a fraction of a second, but in that blink, the energy they release is more than what our sun puts out in an entire year. Think about that. A single cosmic heartbeat, brighter and louder than the star, that gives us life and then silence. When the first of these signals was found in 2007, scientists thought it must be a mistake. Maybe a glitch in the telescope, maybe static from Earth. But then, more were found. And then, some began to repeat. Like an unknown lighthouse out there in the darkness, blinking again and again, sending out a message we don't yet understand. What causes them? Some say they could be from neutron stars, the collapsed cores of massive stars, spinning and crackling with magnetic energy. Others think they could be the violent deaths of stars colliding, ripping the very fabric of space. And then there are the whispers of something less natural. Could they be signals from civilizations far beyond us, reaching out without even knowing we're here? No proof, no certainty, just that eerie cosmic tapping. The more you listen to the universe, the stranger it becomes. Take black holes, for example. These are the monsters of space, the cosmic sinkholes where gravity gets so strong that not even light can escape. On paper, they sound terrifying, and they are. Imagine a star bigger than our sun, collapsing under its own weight. The core falls inward, tighter and tighter, until it forms a singularity, a point of infinite density, a place where our math breaks, where the laws of physics as we know them no longer apply. But here's the twist. Black holes don't just sit there waiting to devour. They spin, they warp time, they stretch space. Around them swirls a glowing disk of gas and dust, heated so hot that it shines across the universe. And when they feed, when they pull in matter, they sometimes shoot out jets of energy that scream across millions of light years, like beacons announcing something impossible is happening here. Some scientists believe black holes may hold answers not just about the universe, but about reality itself. There are theories wild, but not impossible, that black holes could be gateways, wormholes, shortcuts to other parts of the universe, or maybe even doors to other universes entirely. But the scariest part? We don't fully understand what happens inside. If you cross the point of no return, what's called the event horizon, you wouldn't see a fiery explosion. You wouldn't even notice the moment you crossed. But from the outside, anyone watching would see you freeze, stretched in slow motion, like time itself was being pulled apart. And maybe it is. Time and space aren't separate. When you get near a black hole, they fold together, bend, twist. It's like dropping a marble on a stretched rubber sheet and watching it roll endlessly around the dent. Only here, the marble is light itself, which makes us wonder. If time can stretch and bend around these cosmic giants, what does that mean for us? For everything we know? Could the universe itself be curved in ways we can't even see? Could time itself be looping, or spiraling, or flowing differently in other corners of space? The more questions we answer, the more doors open. Fast radio bursts, black holes, the strange dance of time. Each mystery feels like a riddle left behind by something greater. And maybe, just maybe, we're only scratching the surface. If black holes bend space and time, then what about the universe itself? Could the entire cosmos be playing with us in ways we can't yet grasp? Scientists often describe space as if it's flat, like a stretched out sheet. But the truth is, the universe might not be flat at all. It could be curved, or warped, or folded in ways our minds struggle to picture. Imagine walking in a straight line across what you think is a flat desert, only to realize after days of traveling that you've circled back to where you started. That's the possibility some cosmologists raise. Maybe our universe is not endless, but instead loops back on itself. If that's true, then the night sky might be more familiar than we think. When you look at the stars, you might actually be seeing the same stars over and over again, their light wrapping around the universe like echoes in a hall of mirrors. In other words, we could be staring at cosmic déjà vu and not even know it. And then there's time. Time isn't just a ticking clock or the rising of the Sunday. It's woven into the fabric of space, inseparable from it. The universe has a rhythm, a flow. And yet, in certain places, that flow doesn't behave the way we expect. Around black holes, time slows down compared to the rest of the cosmos. That means, in theory, If you could hover near a black hole without being torn apart, you could watch the future unfold in fast forward. Hours for you could mean centuries, even millennia for the rest of the universe. But what if time doesn't just slow down? What if it can actually split? This brings us to one of the strangest ideas in physics, the multiverse. Some scientists think our universe might not be the only one. Imagine a book, with each page telling a different story. That book is like the multiverse. We're living out the story of one page, our page. But maybe there are infinite other pages, infinite other universes, each with their own laws, their own stars, their own versions of us. Here's where it gets even stranger. Quantum mechanics, the branch of physics that studies the tiniest particles, suggests that reality itself may split whenever a choice is made. Right now, as you're listening, there might be another version of you somewhere else who paused this video, who went to bed earlier, or who never clicked play at all. Every possibility branching into its own universe, endlessly. And here's the unsettling part. If there really are infinite universes, then there are infinite versions of you. Some might be nearly identical, living lives so close to yours it's eerie. Others might be so widely different you'd never recognize yourself. In one universe, maybe you're living on a planet with two suns. In another, Earth never formed and humanity never existed at all. But how do we know if these other universes are real? That's the problem we don't test. We can't reach them. We can't test them. At least, not yet. All we can do is look at the strange behavior of the cosmos, the way particles act like they're aware of possibilities, the way space expands faster than light, and wonder if those are clues pointing to something bigger. The idea of the multiverse has another chilling layer. If there are infinite universes, then somewhere out there is a universe almost exactly like ours, except for one detail. Maybe in that universe, you took a different job, or met a different friend. Or maybe in that universe, Earth faced a disaster we somehow avoided. The thought is both comforting and terrifying. Every dream, every nightmare, every what-if might exist, playing out somewhere beyond our reach. And yet, as huge as the idea of infinite universes sounds, it doesn't answer the question that keeps us awake at night. Why is there something instead of nothing? That question hangs in the silence of space like a ghost. If there are many universes, where did they come from? If our universe is curved or flat or looping, what started the loop? If time stretches, bends, or splits, then who or what lit the first spark of time itself? NASA has pointed its most powerful eyes into the cosmos, scanning microwave radiation left over from the Big Bang, mapping galaxies billions of light years away, listening for signals in the static. And still, these questions remain unanswered. For every mystery solved, two more appear, like shadows moving just out of sight. So, as we sit here, on this tiny planet spinning around an ordinary star, we're left with a paradox. The more we learn, the smaller we feel. And the smaller we feel, the more we realize that maybe, just maybe, the biggest mysteries aren't out there at the edges of the cosmos. Maybe they're right here. in the fact that we're able to wonder at all. When you step outside on a clear night and tilt your head back, it looks simple. A dark canvas scattered with stars, tiny lights pinpricked across the sky. But here's the truth. That view is a trick. What you see is only a fraction of what's out there. Like shadows on the wall of a cave, we're only glimpsing hints of a much stranger, much larger reality. Let's start with one of the strangest illusions in the cosmos, the way galaxies move. In the 1972nd, an astronomer named Vera Rubin made an unsettling discovery. She found that stars at the edges of galaxies were moving far faster than they should. According to the rules of gravity, those stars should have been flung into the emptiness of space. And yet, they weren't. Something invisible was holding them in place. Something that didn't glow, didn't shine, and couldn't be seen. That invisible something is what scientists now call dark matter. Imagine walking into a room with furniture you can't see. You bump into a table here, stumble over a chair there, and realize the room is full of objects that aren't visible to your eyes. That's what dark matter is to the universe unseen mass, shaping everything. And here's the haunting part. About 85% of all the matter in the universe is dark matter. That means most of the cosmos is made up of something we can't touch, can't see, and can barely measure. NASA has built satellites, sent telescopes, and gathered data to track dark matter's fingerprints, the way galaxies rotate, the way light bends around massive objects. But it still refuses to reveal its true identity. Is it made of exotic particles we've never discovered? Or is it a flaw in our understanding of gravity itself? No one knows. And just when you think it can't get any stranger, there's dark energy. If dark matter is the invisible glue holding galaxies together, then dark energy is the force pushing the universe apart. In the late 1992nd, astronomers expected to find that the universe's expansion was slowing down as gravity pulled everything back together. Instead, they found the opposite. The expansion is speeding up. Space itself is stretching faster and faster, as if some hidden hand is pulling the fabric of the cosmos outward. To put it simply, every second, the universe grows bigger, emptier, and colder. And here's where things become deeply unsettling. Together, dark matter and dark energy make up about 95% of the universe. That means everything we can see, every star, planet, comet, tree, ocean, animal, and person is only 5% of reality. We are living inside a universe where almost everything is missing from our senses. So when NASA says we don't fully understand the universe, it's not a small admission. It's colossal. It's like admitting you've read the first page of a 1,000-page book and the rest is still sealed shut. And then there are the cosmic illusions. Light doesn't always travel in straight lines. Massive objects like galaxies or black holes bend light as it passes by, warping the view like heat shimmering on asphalt. This is called gravitational lensing, and it means that when we look at a galaxy, we may not be seeing its true form at all. We could be seeing distorted copies, stretched out reflections, or even echoes of galaxies that don't exist anymore. Imagine standing in a hall of mirrors. where your reflection repeats endlessly in warped shapes and angles. Now imagine that happening not in a carnival, but across billions of light years of space. That's what our telescopes are capturing. And here's the eerie twist. Some scientists think gravitational lensing might allow us to glimpse things outside our universe. Flashes, distortions, or anomalies that don't fit with the structures we know. As if the fabric of our reality is thin, in some places, thin enough that other worlds could bleed through. But if the universe is an illusion layered with hidden matter and unseen forces, then what does that make us? Are we passengers inside a cosmic trick, trying to decode rules that were never meant for us to fully understand? NASA's most powerful tool, the James Webb Space Telescope, has already found galaxies so old, so massive, and so structured that they shouldn't exist according to our current theories. These galaxies formed too quickly, too perfectly, too soon after the Big Bang. They are cosmic rule breakers, proof that something about our story of the universe is incomplete. It's almost as if the universe is whispering, "You don't know me as well as you think." And that whisper gets louder the further we look. Because the more NASA uncovers, the more it seems reality itself is built on unanswered questions. Why is the universe accelerating? What is dark matter? Why are impossible galaxies showing up in places they shouldn't exist? Maybe these aren't just questions. Maybe they're hints. Hints that our universe is more alive, more mysterious, and more unknowable than we dare to imagine. Black holes. Just the name itself feels heavy, doesn't it? Like a whisper that carries weight. They're the darkest objects in existence, so dark that even light, the fastest traveler in the cosmos, cannot escape them. If the universe were a theater, black holes would be the backstage curtains, swallowing everything, never letting the audience see what's behind. For decades, black holes lived mostly in the realm of theory. Einstein's equations predicted them, but even he wasn't sure they truly existed. To him, they were like strange mathematical ghosts, curious possibilities, not solid reality. And yet, the universe doesn't care what makes us comfortable. It makes things stranger than we'd like. Today, thanks to NASA and its fleet of telescopes, we know black holes are real. They're not just real, they're everywhere. At the center of almost every galaxy, including our own Milky Way, lurks a supermassive black hole, a monster with millions, sometimes billions, of times the mass of our Sunday. Ours is called Sagittarius A star. It hides 26,000 light years away, buried in a dense fog of stars and gas, patiently pulling at everything around it. Here's the unnerving part. We've seen stars whip around Sagittarius A star at breakneck speeds, like tiny marbles caught in a giant whirlpool. And yet, we can't see the black hole itself, only its influence, its pull, its appetite. It's like watching invisible jaws bite into the universe and leave no trace but chaos. But what's inside a black hole? That's where things unravel. The outer edge of a black hole is called the event horizon. Think of it like the point of no return. Once you cross it, escape becomes impossible. Not even light, the fastest thing we know, can outrun the black hole's pull. Now picture this. If you somehow drifted too close to a black hole, you wouldn't fall in all at once. Your feet, being closer, would be pulled harder than your head. Astronomers call this spaghettification, the stretching of matter into long, thin strands. It's an almost comical word for something so horrifying. You'd be stretched into oblivion, torn apart atom by atom, long before reaching the core. And yet, the real mystery is what lies beyond that tearing point. The laws of physics, the very rules that govern reality, break down inside a black hole. Our equations stop working. Our understanding collapses. NASA, with all its technology and knowledge, admits it. Black holes remain a blank spot in the book of the cosmos. Some scientists believe at the very center of a black hole is something called a singularity, a point where all matter is crushed into infinite density. Imagine squeezing an entire star, or an entire planet, or even an entire galaxy into a dot smaller than a grain of sand. A place where space and time themselves fold into something we can't even picture. Others think black holes might not just be destructive. They could be gateways, doorways to other universes, wormholes hidden in plain sight. Imagine this. What if every black hole in our universe is connected to another reality? A kind of cosmic recycling system where what falls in here is reborn somewhere else. If that's true, then black holes aren't just the universe's monsters, they're also its creators. Silent architects of other worlds we may never see. And here's where it gets eerie. NASA's James Webb Space Telescope has spotted black holes that are too big too early. According to our models, it should have taken billions of years for them to grow into these giants. And yet, they were already massive only a few 100 million years after the Big Bang. That means either we're missing something big about how black holes form, or the universe has a trick up its sleeve that we haven't even begun to understand. Now think about this for a moment. Black holes don't just sit quietly. They shape the galaxies around them. Some even shoot out jets of energy that stretch for thousands of light years, cosmic flamethrowers blasting across space. In a way, black holes are both destroyers and sculptors. They kill, but they also create. And maybe that's the biggest mystery of all. Maybe the universe itself is built on contradictions. Things that shouldn't exist, but do. Things that seem like endings, but are actually beginnings. When NASA looks at black holes, they see puzzles that don't just bend space, they bend understanding. These objects are so strange, so alien, that they almost don't feel real. And yet, every time we peer deeper into the cosmos, we find more of them, quietly waiting, silently pulling. The universe keeps its darkest secrets not in faraway galaxies or hidden corners, but right at its very heart. And black holes are its way of reminding us we don't know as much as we think we do. Time is the one thing we all live by, yet barely understand. We wear it on our wrists. We check it on our phones. We feel it pass in our bones. But what exactly is time? Is it a real thing, like a river flowing in one direction? Or is it just a trick? A shadow cast by something deeper? When NASA looks at the universe, time becomes slippery. Our clocks, the ones ticking on Earth, don't always agree with the clocks moving through space. That's not science fiction. That's Einstein's theory of relativity, proven again and again by satellites orbiting just above us. If you put two identical clocks side by side, one on Earth and one flying through space, they won't tick the same. The one in space moves just a little bit differently, slightly ahead. A fraction of a second, but measurable. Time itself bends depending on where you are and how fast you're moving. Think about that for a second. You could be standing still, and someone else moving quickly through space could literally be living in a slightly different version of the present. That means now isn't the same for everyone. Your now isn't my now. In a universe this big, time is personal, relative, almost fragile, and it gets stranger. Near a black hole, where gravity is unimaginably strong, time slows down even more. Imagine standing close to one of those cosmic monsters. For you, a few minutes might pass. But for someone far away, outside its pool, years could drift by. This isn't theory, it's written in the math, it's physics, it's reality. NASA uses this knowledge every single day. GPS satellites wouldn't even work if they didn't account for time running differently up there than it does down here on Earth. Without relativity, your phone's map wouldn't know where you are. The satellites in orbit are literally living a slightly different time than you are, and we depend on that difference to find our way home. But if time bends and stretches, does that mean it can break? Some scientists think time might not be fundamental at all. Maybe it's not a river flowing forward. Maybe it's an illusion, like the hands of a clock moving in circles, pretending to be something deeper. Think about the Big Bang. We say it happened 13.8 billion years ago, but years ago is a human idea. Before the Big Bang, what was there? No stars, no galaxies, no clocks. Did time itself even exist? Or did time begin with the universe? NASA's telescopes peer further back every year. The James Webb Telescope, for example, is looking at light that left galaxies over 13 billion years ago. We are literally seeing the universe as it was when it was still an infant. But even then, the question hangs in the dark. What came before? Was there a before at all? Or is time just a story the universe tells itself? And then there's the other direction, the future. We like to think of time as a straight line, moving forward, never backward, but physics doesn't always agree. Many equations work just as well if time runs forward or backward. The arrow of time, as scientists call it, seems to be tied to something called entropy, the way things naturally move from order to disorder. A sandcastle crumbles into sand. A cup shatters into pieces. But why don't we ever see the opposite? Why doesn't the sand rise up into a castle? Why don't broken shards leap back into a perfect cup? NASA doesn't have that answer. No one does. All we know is that the universe seems to prefer one direction, forward, toward chaos, toward heat death, toward an ending none of us will see. But here's the haunting twist. If time is relative, if it bends and stretches and maybe even folds, then maybe everything that has ever happened still exists. Right now, this moment, you listening to my voice, it might be etched into the fabric of space-time forever. Somewhere, in some frame of reference, you're still a child. Somewhere, you're still yet to be born. Somewhere, in the deep fabric of the cosmos, your story is already written. NASA has no way to confirm or deny this, and that's the terrifying beauty of it. Time is both our most familiar companion and our greatest mystery, and so we live by it. We age, we wait, we hope. While the universe itself seems to whisper that time is not as simple as the ticking of a clock, that the truth is bigger, stranger, almost unreachable. If time is slippery, then matter, the stuff we're made of, should be simple, right? Tables, chairs, mountains, planets, stars, solid things, things we can touch, things we can measure. But here's the unsettling truth. Everything we see, touch, and know is barely a fraction of the universe. Just 5%. The rest 95% is invisible, mysterious. And NASA can't tell us exactly what it is. They call it dark matter and dark energy. Two names that sound like science fiction, yet they are as real as the stars above us. Let's start with dark matter. Imagine spinning a toy around on a string. The faster you spin it, the tighter you have to hold on, or the toy will fly away. Galaxies work the same way. Stars spin around the center, and according to the math, many of them should be flying off into the void, escaping, like toys flung from a broken string. But they don't, they stay. They cling to their galaxies. Something is holding them in place. Something heavy, something invisible, something we can't see with any telescope. That unseen weight is what scientists call dark matter. It doesn't shine. It doesn't glow. It doesn't absorb or reflect light. To our eyes, it's nothing. Yet, its gravity pulls with silent strength. It holds galaxies together like an invisible skeleton. Without it, the universe as we know it would fall apart. NASA's telescopes map this ghostly scaffolding not by seeing it directly, but by watching how light bends around it. Like a glass lens bending sunlight, dark matter warps the light from distant galaxies. And through that warping, we know it's there, not a theory anymore, a presence, a hidden reality. Now, if that wasn't strange enough, there's something even more baffling: dark energy. Dark matter pulls things together, but dark energy, it pushes things apart. For years, astronomers thought the universe's expansion might slow down. After all, gravity should pull everything back. Like tossing a ball into the air, eventually, it slows, stops, and falls. But the universe doesn't obey that rule. In the late 1992nd, NASA scientists and others around the world discover something shocking. The universe isn't just expanding, it's speeding up. faster and faster. Every second, galaxies are being carried farther apart, as if some invisible hand is pushing them away. That hand is what we call dark energy. It makes up nearly 70% of the cosmos. 70%. Think about that. The universe is mostly made of something we can't explain, can't see, can't touch. We live in a universe where the majority is unknown. And here's the haunting part. We don't know what dark energy will do in the long run. If it keeps pushing, galaxies will drift farther and farther away. Stars will burn out. Light itself will fade. Billions of years from now, the night sky might be empty, every galaxy too far to see. A universe stretched so thin that it's cold, dark, and silent. Astronomers call this the heat death of the universe. The ultimate quiet. But others wonder, maybe dark energy will change. Maybe it will grow stronger. Maybe it will tear galaxies, stars, even atoms apart. Imagine the fabric of existence ripping piece by piece until nothing remains. That terrifying possibility is called the Big Rip. And yet, there's another thought. What if dark energy slows? What if the expansion halts and gravity wins in the end? Then everything would collapse back inward. Galaxies colliding, stars crashing together, time itself folding back. Scientists call that the Big Crunch. 3 possible endings: heat death, Big Rip, Big Crunch, and NASA, with all its telescopes and probes and data, still can't tell us which is true. So we live suspended in the middle of a mystery. A universe whose true ingredients are invisible. A cosmic recipe where 95% of the ingredients can't even be named. And here we are, fragile creatures of flesh and thought, trying to make sense of it all. The next time you look up at the night sky, remember, most of what you see isn't there. The stars are just a thin sprinkle of light across a vast, invisible ocean. And beneath that ocean lies the secret that NASA still struggles to explain. If dark matter and dark energy are the invisible frameworks of the cosmos, then black holes are its traps, its monsters. Silent beasts that lurk in the dark, waiting, pulling, swallowing. A black hole is not just an object. It's a place where the rules of the universe break, where the fabric of space and time folds in on itself, where gravity is so strong that nothing escapes, not even light. Think about that for a moment. Light, the fastest thing we know, the very speed limit of the cosmos, can't get away. Once it crosses the edge of a black hole, it's gone. Forever. That edge is called the event horizon. To us, it looks like a shadow, a perfect circle of darkness, surrounded by a glowing ring of hot, tortured gas. But here's the strange part. Black holes aren't rare. They're everywhere. NASA estimates there could be millions of them in our galaxy alone. Millions of invisible predators scattered across the Milky Way. Most are small, created when massive stars die. Their cores collapse, crushing matter into a point so dense, so heavy, it bends reality itself. And then there are the giants, supermassive black holes. They sit at the centers of galaxies, including our own Milky Way. The one in our galaxy is called Sagittarius A, and it's 4 million times the mass of our Sunday. Imagine that. A black hole so enormous, so heavy, that entire stars orbit around it like planets around a fire. NASA and the Event Horizon Telescope gave us our first picture of one in 2019, a blurry orange ring around a shadow. That image went viral. But here's the unsettling truth. We still don't fully understand what happens inside. Cross the event horizon and time itself starts to behave strangely. To an outside observer, you would appear to slow down, stretched out, frozen. But to you, falling in time would feel normal. You'd cross the horizon without noticing, and once inside, no force in the universe could pull you back. And what lies at the very center, that's the deepest mystery. Scientists call it a singularity, a point where density becomes infinite, where the math breaks down, where our laws of physics simply stop working. Einstein's equations, quantum mechanics, the rules that explain everything else, none of them can describe what happens there. It's as if black holes are windows into another reality, gateways that hint at something beyond our understanding. Some scientists even suggest black holes could connect to other universes, tunnels known as wormholes. Pure speculation, yes, but tantalizing. If true, then black holes wouldn't just destroy, they might transport. Imagine falling in and emerging somewhere else, in another galaxy, another universe, or maybe in another version of reality entirely. And yet, NASA admits, we don't know. What we do know is this. Black holes shape the universe in ways we're only beginning to grasp. They don't just consume, they create. Their immense gravity stirs up galaxies, ignites star formation, and powers the brightest lights in the cosmos, called quasars. Beams of energy so powerful they can outshine trillions of stars. So we're left with this paradox. Black holes are the darkest things in existence, and yet they may be the engines that keep galaxies alive. But maybe the most chilling thought of all is this. Black holes are patient, eternal. While stars burn out and galaxies fade, black holes remain. Slowly, quietly, waiting. And in the very far future, when the universe has gone dark, they may be the last things left. Silent keepers of secrets, holding answers we may never live to hear. So when you look at the night sky, know this. Among those twinkling stars, somewhere in the shadows, are invisible giants. And though NASA has studied them for decades, their true nature remains hidden. A puzzle with no final piece. If black holes are the monsters of the universe, then the cosmic horizon is its curtain, the final wall of sight, the edge of everything we can possibly observe. Right now, with the help of NASA's most powerful telescopes, we can see about 46 billion light years in every direction. That's what we call the observable universe. Not because that's all that exists, but because that's all the light has had time to reach us since the Big Bang, 13.8 billion years ago. Think about it like this. The farther out we look, the farther back in time we're seeing. Point a telescope deep into space, and you're not just looking at distance, you're looking at history. at galaxies as they were billions of years ago, at starlight that left its home before Earth even existed. But here's the catch. Beyond that horizon, beyond that limit, there's more. More stars, more galaxies, more everything. NASA admits it openly. The universe doesn't stop at the edge we can see. It stretches farther, maybe infinitely farther, and yet we can never know for sure. The light from those distant regions will never reach us. The expansion of the universe is pulling them away faster than the speed of light, taking them beyond our grasp. It's like standing on the beach, looking out across the ocean. You can see the water stretch to the horizon, but you know the sea goes on, endless. That's our universe. The horizon isn't an edge, it's just as far as our eyes can go. But here's where the mystery deepens. If we can only see a fraction of the universe, what lies beyond? Are the galaxies out there the same as ours? Do they follow the same laws of physics? Or could things be entirely different? Some scientists propose that far beyond our horizon, the universe may not look familiar at all. The laws of nature, the constants of physics could shift. The strength of gravity, the pull of electromagnetism, even the way atoms form, all might change. Out there, light itself could behave differently. Stars might not shine. Matter might not even clump together. It could be a cosmos unrecognizable to us. And then there's an even wilder idea, that what lies beyond our cosmic horizon isn't just more universe, but other universes. A multiverse. Each one with its own rules, its own beginnings, its own destinies. Imagine bubbles in an infinite cosmic ocean, each bubble its own reality, floating side by side, forever separated by horizons we can never cross. If that's true, then our universe is not the universe. It's just one of many, a single story among countless others. NASA doesn't claim to know the truth here, and that's what makes it so fascinating. Their instruments measure, their equations predict, but beyond the horizon, it's guesswork. The universe hides its secrets behind distance, and time, and silence. But let's come back to our own horizon for a moment. The farthest thing we've ever seen, the faint glow of the cosmic microwave background, the afterglow of the Big Bang itself, a ghostly light stretched thin across the entire sky, so ancient that it carries the whispers of creation. When NASA's COBE, WMAP, and Planck satellites mapped that glow, they discovered tiny ripples in it, patterns, imperfections, like fingerprints left behind from the birth of everything. Those ripples seeded galaxies, stars, and planets. Without them, the universe might be a smooth, empty void. But because of them, structure formed. You and I exist because of the faintest fluctuations in light, frozen in place nearly 14 billion years ago. And yet, even that light has a limit. Beyond it, darkness, silence, a realm we can never reach, never measure, never see. So the question remains, is there an edge to the universe, a wall, a border? Or is infinity itself the answer? Infinity is hard to grasp. It's not just a really big number. It's forever, endless. If the universe is infinite, then somewhere out there, beyond our horizon, is another patch of sky identical to ours. Another Earth. Another you, sitting in another room, listening to another story about the unknown. Does that sound impossible? Maybe. But the math doesn't rule it out. And that's the strangest part. Infinity doesn't just mean a lot. It means every possibility exists somewhere. Every story, every outcome, every version of reality. And so, as we stare at the edge of the observable universe, we're left with a paradox. We've mapped billions of galaxies, billions of light years, but we may never know if what we've seen is just a grain of sand on an endless cosmic shore. The truth is, we don't know where it ends, or if it ends. And maybe we never will. But maybe that's the beauty of it. That the universe keeps its biggest secret just out of reach. That no matter how far we go, how deep we look, there will always be a horizon daring us to imagine what lies beyond. We've talked about black holes, we've talked about dark matter, dark energy, and the invisible structures holding the universe together. We've even wandered out to the cosmic horizon, the very limit of what we can see. But now comes the ultimate question, the one that has haunted not just NASA, but every scientist who has ever stared into the night sky. How does this all end? Every story has a final chapter. Every star that is born will one day burn out. Every galaxy will one day fade. And the universe itself, vast, infinite, mysterious, is not exempt from that truth. NASA has many models, many theories. But the frightening reality is that no one truly knows. The universe doesn't hand out spoilers. It only gives us clues. And those clues point to possibilities so strange, so awe-inspiring, that they sound almost like science fiction. Let's start with the most likely scenario. According to current data, the heat death. Right now, dark energy is driving the universe to expand faster and faster. Galaxies are drifting apart. The farther away one is, the quicker it escapes. Over billions of years, this expansion will stretch everything apart until galaxies vanish beyond the cosmic horizon. Future civilizations, trillions of years from now, may look at the sky and see nothing but darkness. No galaxies, no stars, just an empty void. Stars, of course, won't live forever. Even the longest living red dwarfs will eventually exhaust their fuel. Planets will freeze. Black holes will consume what they can, then themselves evaporate over unimaginable timescales through something called Hawking radiation. What's left is silence. A universe where everything has thinned out, spread apart, cooled down. No light, no warmth, no life. Just endless emptiness approaching absolute zero. That's one possible ending, cold, slow, inevitable. The universe dying not with a bang, but with a whisper. But there are other theories. Some more violent, some more bizarre. Take the Big Crunch. This idea suggests that one day the expansion will stop. Gravity will take over. Galaxies will slow their drift, then reverse, crashing back together. The entire universe collapsing inward faster and faster until everything compresses into a single, unimaginably dense point, not unlike the moment of the Big Bang itself. If that happens, does the story end there, or does it begin again? Some scientists speculate that a new Big Bang could burst forth from that collapse, igniting a new universe, one that may or may not resemble ours. If that's true, then the universe doesn't end at all. It simply resets, an eternal cycle of birth, death, and rebirth. Now, there's another possibility, one even stranger. The Big Rip. If dark energy doesn't just keep expanding the universe, but actually grows stronger over time, then eventually it could overwhelm every force in existence. First, galaxies would be torn apart, then solar systems, then planets, then atoms. Finally, space-time itself would rip to shreds. Imagine the fabric of reality unraveling like old cloth until there's nothing left to hold anything together. That would be the Big Rip. It's hard to picture, harder still to accept, but the math allows it. And NASA's telescopes continue to measure dark energy, hoping for answers. But wait, there's more. Some cosmologists talk about vacuum decay. This theory suggests that our universe exists in a false vacuum, a fragile, temporary state of energy. Somewhere far away, a tiny bubble of true vacuum could spontaneously appear. And if it does, it would expand at the speed of light, rewriting the laws of physics as it passes. Everything atoms, stars, galaxies would vanish instantly without warning. No pain, no time to react, just gone. It sounds terrifying, but oddly, it's also peaceful. If that's our ending, no one will ever know. It will simply happen, and that will be that. And then, of course, there's the possibility that we haven't even imagined the real ending yet. Maybe the universe has tricks we can't see, physics we don't understand, endings stranger than any model we've dreamed of. But here's the strange comfort. No matter which theory turns out to be true, all of them unfold on timescales so vast, so unthinkable, that they make our own lives seem like flashes of lightning in a storm. Whether it's the Big Crunch, the Big Rip, the heat, death, or something else. We're talking about billions, trillions, even quadrillions of years. Long after the last star fades, long after the last galaxy disappears, long after even black holes have crumbled into nothing. We won't be here to see it. No civilization will. Perhaps no consciousness at all. And yet, as you sit here listening to this, as you breathe in the calm of this moment, you're part of that grand story. Part of a universe that is alive, burning with stars, brimming with mystery. Right now, galaxies swirl, stars explode, planets form, and life stirs. Right now, the cosmos is awake. And maybe that's the point. Not how it ends, but that we exist within it. That for this brief window, we can look up, wonder, and try to understand. NASA can't explain everything. The universe keeps its secrets. But maybe that's not a flaw. Maybe that's the gift. that the mystery is what keeps us reaching, questioning, dreaming. Because if the universe answered every question, if it revealed every secret, maybe it wouldn't be so beautiful. So, the fate of the universe? We don't know. And perhaps we never will. But as long as the stars shine, as long as we can look up into the night, we'll keep asking, we'll keep searching, and we'll keep telling stories about what lies out there beyond what NASA can explain. And so, we come to the end of our journey tonight. From the silent drift of Voyager, carrying its golden record through the void, to the great cosmic web of galaxies stretched across the universe like threads of light, to the unfathomable possibilities of black holes, dark energy, and the fate of all existence, we've traveled far, further than our bodies ever could, beyond the reach of rockets, beyond the limits of telescopes, and deep into the realm where science and wonder meet. What have we learned? That the universe is vast, that mystery is everywhere, and that even NASA, with all of its instruments, discoveries, and genius minds, cannot explain it all. Some questions remain untouched. Some secrets refuse to be revealed. And maybe, just maybe, that's exactly what makes the universe so endlessly captivating. Because mystery keeps us moving forward, it keeps us gazing into the night sky, keeps us sending probes, keeps us writing, dreaming, and imagining. Mystery is the heartbeat of discovery. And as you sit here in your own quiet corner of Earth, remember this: you are part of this universe. The atoms in your body were forged in stars that exploded billions of years ago. You carry their light, their dust, their memory. The cosmos is not just out there, it is within you. So the next time you look up into the night sky, let yourself wonder, not with fear, but with curiosity, not with dread, but with awe. The mysteries of the universe are not here to terrify us. They're here to remind us that we are small, but also that we are part of something infinite. And if you found yourself drifting with me tonight, if the mysteries have caught your imagination, if the cosmic silence has made you think, dream, or even feel just a little less alone in this vast universe, then I invite you to stay. Subscribe to the channel. Join this growing community of seekers, dreamers, and wanderers of the unknown. Together, we will keep unraveling mysteries not just of space, but of time, history, the paranormal, and the unseen forces all around us. Because there will always be another question, another mystery, another story waiting to be told. So, until the next video, keep looking up, keep wondering, and keep remembering. The universe may not give us all the answers, but it always gives us something worth seeking. Good night.